The physical layer of the OSI model has many jobs. One is to transmit and receive bits over the physical media or the network cabling. Another job is to control the physical layout of the network and define the rules for bit translation, encoding, and timing. These include network connection types, physical topologies, analog and digital signaling, bit synchronization, baseband and broadband transmissions, and multiplexing. Let's begin with connection types. Basically, there are two main types of network connections, multipoint and point-to-point. Connection types define whether or not multiple devices are connected to the medium or if there is a one-to-one connection. A good way of judging this is that if two devices are connected, the connection type is point-to-point. If three or more devices are connected, the connection type is multipoint. When using a multipoint connection type, multiple devices are connected to the transmission medium. For example, there are 4 devices connected to this network cable. These devices will share the same cable, and the cable bandwidth will be divided among the 4 devices. When using a point-to-point connection type, 2 devices are connected to the transmission media. For example, there are 2 computers that are connected via a modem. This is a point-to-point link. The second topic that the physical layer is involved with is the physical topology. Physical topology deals with a network's physical structure or layout. Let's take a look at several topologies. The first topology we'll discuss is the physical bus topology. A bus topology has what is called a backbone configuration. In this type of configuration, all computers are tied into one long cable segment. This is also considered to be a multipoint connection. With a bus topology, both ends of the network must be terminated. This is to avoid signal reflections that will cause the network to crash or quit responding. All the machines attached to the cable segment are connected with some type of connector. Usually, this is a T-connector. In some types of bus topologies, the machines are connected to the long cable segment with short drop cables. These cables are about 2 to 4 feet long and connect the main network cable segment to each machine. Installing a network with a bus topology is usually an easy process. We do, however, need to follow certain guidelines. These guidelines include the maximum backbone cable segment length, minimum distance between devices, and also using network terminators. The most common type of a bus topology network is the Ethernet network. Devices must be at least 8 feet apart. Troubleshooting this type of topology can be difficult. If there is a cable break or a bad connection at any point on the segment, the entire network is affected. One advantage of a bus topology is that it uses less cable than the other topologies. The main disadvantage is, of course, that all devices on the network are affected by one device going down.